The 6.7-year, 5 billion kilometer transit journey of the Cassini probe was slightly longer than the direct Hohmann transfer. The mass of the Cassini spacecraft was such that even with the Titan IV launch vehicle, Cassini needed added help to reach Saturn. So, to gain momentum, the Cassini mission included several gravitational slingshot maneuvers. 2 flyby passes of Venus, 1 of the Earth, and then 1 from the mighty planet Jupiter. The Cassini orbiter then spent several years orbiting and maneuvering around the planet and its moons, finally diving through the inner rings of the planet.
When we go into the proximal orbits between the rings and the planet, we've never been there before, and we'll be a little bit more concerned. Here, we've actually been closer to these rings, the Janus Epimetheus ring and the F ring, when we went into orbit around Saturn. So this is not unexplored territory at this point. The nice thing about this, though, is that we've got a much better viewing angle of the rings because of the sun this time around.
And eventually into its atmosphere. The New Horizons spacecraft had further to go than Cassini, but being far less massive a probe, it was able to be launched directly towards Jupiter. The spacecraft was launched in 2006 and made its way to Jupiter. Its closest approach happened only a year after its departure, at a distance of 2.3 million kilometers. The flyby provided a gravity assist that increased the probe's speed. It also allowed for a general test of New Horizons' scientific capabilities, returning data about the planet's atmosphere, moons, and magnetosphere. Most of the post-Jupiter voyage was spent in hibernation mode to preserve onboard systems. In 2014, New Horizons was brought back online for the Pluto encounter. It flew 12,500 kilometers above the surface of Pluto, making it the first spacecraft to explore the dwarf planet, and then on into the Kuiper Belt towards its next target, a Kuiper Belt object most likely composed of frozen volatiles or ice, such as methane, ammonia, and water. A future probe to return to Jupiter's moons is destined for another multi-year journey. JUICE, to be launched in 2022, will embark upon a 7-year odyssey, taking the spacecraft via an Earth swing-by, then to Venus, back to Earth with a slingshot to Mars, then back to Earth for a final kick, direct to Jupiter. Heading outward bound is one thing, but launching payloads inward towards the Sun is another set of problems. For example, the Bepi-Colombo mission to Mercury, launching this year, will require 9 gravity assist maneuvers. After launch, a 2-year journey using ion propulsion will bring it back to Earth for a kick towards Venus. Followed a year later by another flyby of Venus, sending it closer towards the orbit of Mercury. In the following 4 years, the spacecraft will pass by Mercury, tightening its heliocentric orbit until it can match Mercury's speed, and with the aid of chemical rocket motors, insert itself into that planet's orbit in 2025.
So studying Mercury is crucial to better understand the formation of our solar system, how Earth is formed and evolved, and where we are coming from. So Mercury is in a way a missing piece in the big puzzle of the formation of the solar system, and a crucial end member because it's close to the Sun, and if you want to get this full picture, you have to look at the planet close to the sun, as we also did in past missions that we were looking at the comets or planets further out.
Our main target is the environment around the Mercury, especially the interaction between the solar wind and the Mercury magnetosphere.
Mercury is 3 times closer to the sun, and therefore the radiation or the heat which we are getting from Mercury is 10 times higher. So everything which we had to develop had to withstand the higher temperatures, but also the higher radiation doses which we got from the solar wind. And for that we need special insulation of our spacecraft, special materials to be developed for the antenna, for the solar panels. And that was a very big challenge for the mission in itself.